Hey everyone, it is me, Miss B, and in today's video we are looking at Unit 2, Lesson 6, the practice problems from Illustrative Math Algebra 1. So let's jump in. Now, and on my directions here, it says you have to justify your thinking as you answer each question and basically show your work to earn full credit. So with these multiple choice ones, I'm going to put a little bit of an explanation off to the side. That way I can explain what I am doing. So which equation is equivalent to the equation 6x plus 9 equals 12? Well, I see some options here, but it says which, so that tells me this probably means only one. So if it says which, and since it says equation, not equations, this means just one. So what I want to check if I'm looking for an equivalent equation is on my original equation here, I'm looking to see if I can multiply or divide anything here to create the equations on the side, or if I can add or subtract anything to make them equivalent as well. So like what operations can I do to make everything here be equal? So with this top one, it looks like they went from x to 6x to x, right? And then they went from 12 to 6. So it looks like they tried to subtract 6 from both sides. But if we're subtracting 6, it's not going to cancel out the 6. It's going to subtract from the 9. So A is not an option for us. 2x plus 3 equals 4. 2x plus 3 is equal to 4. This one looks like they were dividing everything here by 3. So let's double check. If I divided everything by 3, that would give me 2x. 9 divided by 3 is 3, and this 12 divided by 3 is 4. So B is actually going to be my correct answer. It is divided by 3. But just for you all, I'm going to go through and we can look at the rest of these and see why they're not true. So C here, um, this looks like what they attempted to do was divide everything by 2, but you can't divide 9 by 2. And they also just, well, you can have 9 over 2, but they just divided these two terms by 2. And that's not everything, so it's not going to be equivalent. And then with 6x plus 12 equals 9, they tried to move the numbers to the different sides, but when you just try to shift the number across an equal sign, you have to change its sign. So if you're crossing over the equal, you would change this to be a negative 9. So in our original equation, this 9 would be negative 9 on the right-hand side, and 12 would become negative 12 over here. So if this was 6x minus 12 equals negative 9, that would be correct, but since it's not, it is not an option. So that means, like we said, it is just one answer, and that one answer is B. We are going to do number 2 here, which is now select all the equations. So all means more than one, possibly, because we have to look at each of these. So all of them that have the same solution as 3x minus 12 equals 24. So what I find is we can do the same thing where we just try to see, is there something that multiplies or divides or adds or subtracts to make this equal? But the same steps we would take as we solve the equation are potentially here as well. So one of the things I'm going to do, and if you're just not sure, you can actually solve the equation and then use that answer and plug in. So I'm going to zoom in over here, and I'm just going to show my work and solve for this one here. So I'm sorry it's a little blurry, but that's what happens when I have a screenshot of a question. So if I added 12 to both sides, oops, need my pen there, plus 12 and plus 12. We can separate our sides of our equation here just to show that I'm solving. Adding 12 to both sides is going to get rid of this 12 on the left and just leave us with 3x. And on the right-hand side, we would have 24 plus 12, which is 36. Then if we were to do another step here, we would divide both sides by 3, and then that would give us x is equal to 12. But 3x equals 36, I actually see that as one of my options. So like I said, sometimes our steps in solving things, as long as we're keeping it balanced, are going to be our answers as well here. So I'm going to select this one, but that is not my only answer. I'm going to have other things here that could be the same. Now, if it also had x equals 12, then that would be perfect, but we don't. Um, if we look at our first question, we can actually, not our first question, our first option, we can actually just try to see and determine how we could change it into the other one and if that works. So I see 15x and I see 3x. I know I would have to do that by multiplying. I know I would have to do that by multiplying um, by 5. And so we can check if everything here is multiplied by 5. So 3 times 5 would give me the 15. 12 times 5 is going to give me 60. And 24 times 5 actually does give me 120. So A works as well. And I'm going to write next to this one, multiplied by 5. And C was one of my steps from solving. This was a step in solving, which is why I chose it, because it did say I have to justify my answers. Now we can look at B. So B, if I have 3x is equal to 12, 3x cannot also be equal to 36. So B cannot be, option B cannot be one of our answers. It just is mathematically impossible. I could have both of them equal to 0, and that would work if x was 0, but yeah. Okay, and then we have x minus 4 equals 8. Now for something like this, we could just plug in 12 and see if that works, and then do 12 minus 4, which does give us 8. So I can show that as one of my answers. I can say 12 minus 4 equals 8 because I plugged in to find what my solution was on the right-hand side, and we can just use this over here. Okay, now the very last one, we have 12x minus 12 equals 24. Something tells me this is not going to quite work out, but I'll show you at least mathematically by plugging things in. 12, if I then multiply it by 12, it's going to be a big number, and then subtract 12. It's not going to be 24. This is 144 minus 12, and that's not equal to 24. So I'm going to put a line through this one because E is not one of our options either. And that's question 2. That brings us then to question 3, which is a question about coins. So Jada has a coin jar containing N nickels and D dimes worth a total of $3.65. The equation 0.05N plus 0.1D equals 3.65 is one way to represent this situation. Which equation is equivalent to that equation? So again, it's when it says which equation, this is just one. So I know I am only looking for one answer, but I'm still going to look through each of them. So I have a bunch of decimals, and when we're using decimals, one of the things that I would do at least is try to get rid of all of them. So let's zoom in here on what we've got. And in order to move my decimal and make this a whole number, I would have to move this twice um, on my 0.05. And I would also have to move it twice to make 365 or $3.65 into a whole number. So if I'm going to then do that same thing to 0.1, I don't have any numbers on the end of the 1, but anytime it cuts off, you can always just assume that there are zeros afterwards. So 0.1, if I need a second number there so I can move things two places, I can put a 0 and land my decimal point there. Um, and this is the equivalent if I'm moving decimal points two places. If I'm moving my decimal two places to the right, that is the same as multiplying by 100. So if you were also doing this on a calculator, you could do that same thing. And 100 makes sense because there are 100 cents in a dollar. So we're really just representing this as um, cents instead of in fractions of a dollar. So that would create 5n, and this would be 10d equal to 365. And so since this is using cents instead of dollars, this basically says, hey, every nickel is worth 5 cents and every dime is worth 10 cents. And altogether, she has 365 cents in her, is it her account or her jar? Her coin jar. So this is an equivalent equation, and I actually see this as option C on our answer choices here. So I can say that this was times 100. And yeah, that's question number 3. The rest of these options, you can see they all equal 365, but they didn't quite move their decimals in the right way. This one didn't move their decimals at all in their first two. They just moved it on the 365, so that doesn't work. Here they only moved it one place and one place, but moved it two for the 365, so that doesn't work. And here they moved it two places, but here they only moved it one because they like ran out of numbers, maybe is what they were thinking. If they had 0.1 and then they were like, okay, well, I ran out of numbers. I can't move it twice, but really that should have been a 0 and become a 10. So A is maybe the closest other option, but none of these work because they did not follow that rule. That brings us then to question 4. We want to select all equations, so select all equations that have the same solution as 2x minus 5 equals 15. So I'm actually going to do sort of the same stuff here, and I'm just going to work towards solving this and then see if any of my steps show up, and then sort of analyze the rest to see if they're actually solutions. So I would start by adding 5 to both sides of my equation. This would leave me with 2x because the 5 would cancel or go away. And then over here, we would have 20. My next step would then be to divide by 2 in order to get the x by itself. And that would leave me with x equals 10. So let's see if 2x equals 20 or x equals 10 is one of our options. I have 2x equals 10. I know that's not true because just x is equal to 10. But I do have 2x equals 20, so I can say this was a step in solving because that's how I found it. Um, so option C, it looks like they took the 2 that was attached to the 2x and they're saying, oh yeah, apply that 2 to the x and the negative 5. But we can't do that because that's going to change the value, and this would then be 2x minus 10 equals 15, so not a valid choice because it is changing the value. Now, we actually do have then 2x minus 20 equals 0. And this one is accurate. This works. It's not normally a step we would take in solving, but it's basically if we went here and instead of adding 5 to both sides, if you subtracted 15, you would end up with 0 and a negative 20 over here. And so that's actually what they have for question D, or option D on this question. So let's circle that one. And I'm going to describe what they did. They subtracted 15. And they did that on both sides. I'm just not going to write both sides. So they subtracted 15. Okay, now question E. Can I manipulate this? Not necessarily. So moving this by manipulating it or moving some of my numbers around, I can technically move some numbers around to make this work. But because I actually solved and I got that x was 10 over on the right, I can actually just plug 10 in and see if this works. Well, 4 times 10 is 40. And 40 minus 10 is 30. So since it makes that true, it means that it has the same solution. And then question F, which is 15 equals 5 minus 2x. It looks like they may have just swapped the sides here, but they actually swapped signs as well, because this 2x is negative. The negative sign goes with whichever number it's in front of, and so that's why we can't just swap orders. 5 needs to be negative, and the 2 would need to be positive in order for it to equal 15. So F is not a choice we're going to use. So for number 4, we had B, D, and E. And that finishes off the front page, so let's move on to the back. So we have question 5 here. A basketball coach purchases bananas for the player on his team. The table shows the total price in dollars, P, of n number of bananas. Which equation could represent the total price in dollars for bananas? Okay, so let's look at our options here. We have a couple different things in the table, and then we have some options. Now, normally, if we're looking at number of items and price, we would generally have, they're saying total price. I like to think of price as a per item thing. So I might refer to this as cost. But the fact is that's a total. So generally, our total cost for an item that we're purchasing would be the number of items, and we would multiply it with the price. But I'm going to specify that this is the single item price. So in this case, our total is P. It's the total price. I refer to it as cost, but their total price. And so just based on that, A looks like the correct answer. We can actually check our work and see if this works for each of these things. So if we take that, let me grab my calculator here. If we take that 7 and we multiply it by 0.59, I get that, yeah, it does work. So I am going to test it for each of these to make sure that it works. So if I take 8 and I multiply it by 0.59, oops, 8 times 0.59. I accidentally hit equal twice there, so it did my multiplication twice, and then I was like, that number doesn't look right. 0.59. Yes, it does equal $4.72. So something tells me that 9 and 10 are going to work as well, but I'll still check them. 9 times 0.59 is $5.31. So yes, that works. And number of bananas, this was N. So effectively, what we are doing is N multiplied by that 59 cents is going to give us our total price. And multiplying by 10 is easy because we just move a decimal point. So if we multiply 10 by 0.59, that is the same thing as taking this decimal point and moving it right here to become 5.9. And what do you know? That's what we have over here for 5.90 or $5.90. For number 6, we're looking at a graph now. So instead of a table, we're looking at a graph. Here is a graph of the equation 3x minus 2y equals 12. Select all coordinate pairs that represent a solution to the equation. So anything that represents a solution means it will be on, this would mean the point is on the line. So what I can do is I can just graph all of these and then see if they land on my line. So 2 comma negative 3. So we're starting at 0, 0. My origin is right here. I'll just put a little highlight mark there for myself. So starting there, and then we are counting, whoops, we're counting x is it's x comma y. So x goes left to right and y goes up and down. And I'm just going to plot these points here. So 2 comma negative 3 would land me right here. 4 comma 0, we would go 4 on our x-axis and 0 up or down, so just right there, and that works. I'm going to label these also. So this was A, this one was B, just so that I know when I'm done and I can look at which ones land on my line and choose those as my answers. So then if I go to 5, it's negative 1. That answer is right here. So that one was C. 0 comma negative 6 means we go 0 left to right and then go down 6. So that would put us here. And that is D. And then E is 2 comma 3. Both positive. So that's going to land us right there for E. Okay, so clearly not all of these points are on the line, but I have 3 of them that are. That is A and B and D. So since these land on the graph, that means that those numbers satisfy those equations, or that one equation that is graphed, but those different sets of numbers do. So I'm going to select A and B and D. That brings us then to question 7. Jada brought home some sugar and strawberries to make strawberry jam. Sugar costs $1.80 per pound, and strawberries cost $2.50 per pound. That would be a lot for strawberries if they cost $7 a pound. Jada spent a total of $19.40. So which point on the coordinate plane could represent the pounds of sugar and strawberries that Jada used to make jam? So they are asking us which coordinate plane, or which coordinate on the plane, like which point, right? If it represents the pounds of sugar and strawberries that Jada used, that means they want to know that it is a solution. And just like the previous question, anything that represents a solution means that that point is on the line. So really, in a roundabout way, they're just asking me to figure out which of these points lands on the line. So that means on the graphed line. And that answer is going to be point B. So I'll just put a little highlight mark around it, and then I will circle my answer. And then let's check. Oh, that is the end of this assignment because my next one is for lesson 7. So that is it for this one. This has been Unit 2, Lesson 6, the practice problems for Illustrative Math, Algebra 1.